Here we are, PreCalc with 2.7 nonlinear inequalities. To solve a polynomial inequality such as x squared minus 2x minus 3 is less than 0, you can use the fact that a polynomial can change signs only at its zeros, the x values that make the polynomial equal 0. Between two consecutive zeros, a polynomial must be entirely positive or entirely negative. This means that when the real zeros of a polynomial are put in order, they divide the real number line into intervals in which the polynomial has no sign changes. Those zeros are the key numbers of the inequality, and the resulting intervals are our test intervals. Okay, so take a look here. If we had x squared minus 2x minus 3, right? We're talking about when is this less than 0. That factors into x plus 1 and x minus 3, which means our answers are negative 1 and 3, right? Negative 1, 3. So negative 1 and 3 are what I call like the big numbers or the hard lines here. Okay, negative 1, and I'll put a big line. 3, I'll put a big line. All right, and then you pick a number inside each spot. Okay, well, in between here, between negative 1 and 3, I would test out 0. Okay, out here, let's test out 5. Out here, you could go with like negative 5. Okay, and you see where it's true. You see where it's true. All right, if I put in negative 5 squared is 25. Minus 2 times negative 5, so that's another positive 10. Negative 2 times negative 5, positive 10. We've got up to 35. Minus 3 is 32. So out here would be 32. Is that less than 0? No. 0. 0 squared minus 2 times 0 minus 3 is going to end up being negative 3. So is that less than 0? Yes. And then we get no. And like a lot of the times, guys, a lot of the times, it alternates. No, yes, no, yes, no, yes. It'll just alternate like that. So here's what we want in between here. Okay, and usually it just copies those inequalities. So no underline, on these. So we are between negative 1 and 3. And also, if you want to get super lazy, x squared minus 2x minus 3 graph. Where is it less than 0? Between negative 1 and 3. So there you go. Okay. Find the zeros of the polynomial. Arrange the zeros in increasing order, smallest to largest. Those are the key numbers of the polynomial. Use the key numbers of the polynomial to determine test intervals and pick a number in that interval. After you pick a number in that interval and test it, it should tell you which one is good, which one is bad, and that's what you got. All right? So how about you push pause and try example 1 on your own. Okay, so not a terrible one to factor here. X minus 3, x plus 2, which means my answers are 3 and negative 2, negative 2, 3. All right, those are like my hard lines or my big numbers is what I call them sometimes. And then my test ones. So out here, let's test out like negative 10. Sometimes going super big, like negative 10, or even bigger, like negative 100, it makes the answer way more obvious a lot quicker than if you pick like just barely over, like negative 3. In the middle, anytime you got a chance to pick 0, guys, always a good test number. And let's go like positive 10. And we want less than 0. Okay, so negative 10 squared is positive 100, and already we're feeling like, okay, this is not going to be less than 0 when you're starting off with 100. See what I'm saying? Like this makes picking bigger numbers sometimes can make it a little easier. Sometimes it makes it worse. If it's tough math up here with big numbers, sometimes a big number would make it worse. But I think this one, negative 10 squared, 100 already, you're like, wow, like this doesn't look like this is going to take it below 0. And it doesn't. 100 minus a negative 10 is up to 110, minus 6. Okay, we're over 100. We're definitely not less than 0. This is going to be a no. 0, 0, 0, negative 6. Yep, that's less than 0. Yes. 10, again, we're going to be in the same situation with 100 right away. That's going to be real tough to get under 0. No. So here we are in the middle. Again, negative 2 is less than x is less than 3. All right, we can use the graph to double check. There it is. You can see the exact picture. Okay. Again, they gave us less thans in the problem, so we're using less thans in the answer. Okay, getting a little more complicated. 3x to the third minus 4x squared minus 12x. Let's add the 16 over. Plus 16 greater than 0. Okay, you're like, oh man, 4 things. Think back to your factoring strategies. What's a good factoring strategy for 4 things? Factor by grouping. Parentheses around the first 2, parentheses around the last 2, including that leading sign. So what can I take out of the first one? 3x to the third minus 4x squared. I could take an x squared out of both. 3x minus 4. This should give me a hint at what I want my second one to be. Right? I want my second set of parentheses to also be 3x minus 4. So if I take out a negative 4, we'll get positive 3x, and now it's minus 4. Okay, now these two go in a set of parentheses, x squared minus 4. Those two matched, perfect, 3x minus 4. So we just undid the foiling process right there. All right, if you want to walk that back up, this would be foiling. X squared times 3x, x squared times minus 4, right? X squared times this whole thing. Negative 4 times 3x, negative 4 times negative 4, or just negative 4 times that whole thing. Okay? That's all we're doing. This one now splits difference of squares, x minus 2, x plus 2, and we still have the 3x minus 4. So, after all that work, my answers are negative 2, positive 2, negative 2, and positive 4/3. Number line, negative 2, 4/3, positive 2. Okay, outside of negative 2, let's test out like negative 5, 0, 4/3 and 2. There's not a whole lot left in there, man. That's a tough one, like 1.9. 4/3 would be 1.3, maybe 1.5 would be more of a common sense one there, 1.5, and then like 5. We might not even need that, right? We know it alternates. Okay, greater than, okay? So negative 5. Yikes, that's going to be not a very nice one. 3 times, parentheses, negative 5 to the third, minus 4 times, parentheses, negative 5 squared. When you're testing a negative, it's going to be super important to use those parentheses, especially when you have even powers. Minus 12 times, parentheses, negative 5. Okay, don't forget now this is actually a plus 16. Is that greater than 0? Negative 399, is that bigger than 0? No. Okay, what about 0? 0, 0, 0, positive 16. Yes. I'm not even going to test it out. I'm just going to trust it. Yes, no, yes. Okay. So this one's between negative 2 and 4/3. And then greater than 2. So we got like a limited range here, and then it's just here off to infinity. Okay. Nothing too special about this one, just that it is a number with x or a number in front of x squared. So that can make it tricky. You know, sometimes instead of going through and doing the process, sometimes it's just easier to guess and check. This is obviously going to need to have a 3, and there's only one way to get 3x squared. One of them's got to be a 3, one of them's got to be 1. Limited choices here with -4. You either got 2, 2, or 4, 1, and we need a -11 in the middle. So that's kind of screaming that we need the 3 times a 4, and then plus 1 to bring it back down to just -11. So our answers are -1/3, +4. 0, -5, 5. All right, you can go through and do the test intervals there. We should be getting yes, no, yes. So we are outsides. We are x is less than -1/3, or x's are greater than 4. All right, just some weird ones here, guys. Some weird answers. They all have unusual solution sets. Okay, so it sometimes can help to check it out on the graph right away. X squared plus 6x plus 12. Where is that greater than 0? Oh, wrong way. X squared plus 6x plus 12. Graph, not clear. Where is that greater than 0? It's always greater than 0. Okay, it never crosses the line. So it's always greater than 0. That's going to be always, all real numbers. Less than or equal to 0. Let's check this one out. X squared plus 4x plus 4. It's never less than, but it is equal to 0 at one spot, -2. Okay, x equals -2 is the only spot that it's less than or equal to 0, because it is exactly equal to 0 at that spot, and that's the only one. Okay, similar to A, and you can graph this if you want, similar to A. Where is this less than 0? This is pretty similar. It's up here again. Never goes below. So it never goes below. It's never less than 0. No solutions. All right, and this one's going to be similar to B. All right, this one should hit at 3. So where is it greater than 0? Everywhere except 3, because this is not a greater than or equal to, this is just greater than, and it's actually equal to 3 at 0, so everywhere except 0. All x except 3, or we could say x is not equal to 3. Okay, rational inequalities. Okay, still the same game. Still the same game. Key numbers are what's going to make the top equal 0 and also the bottom equal 0, because those would be vertical asymptotes, and then we can switch signs there. So again, we want this less than or equal to 0, so we're going to -3. All right, then a little pre-calc level math here, all right? We got to get a common denominator. So instead of -3/1, we're going to want x minus 5, x minus 5. So we'll have 2x minus 7, -3 times x. -3 times -5 is plus 15 all over x minus 5. -1x plus 8 over x minus 5. Okay, so where would the top be 0 at? Well, if x was 8, negative 1 times 8 is negative 8, plus 8 would be 0. So we're looking at 8. And what also makes the bottom equal 0? 5. So 8 and 5 are our special numbers on the number line, our key numbers, 5, 8. All right, and the tricky part here is we're so used to like just copying whatever that is, because 5 came off of what makes the denominator equal 0. I can't have that one be like an equal to, right? That one has to be like a less than or a greater than. So we're going to put an open dot here to remind ourselves of that. That gets a little tricky. Okay, otherwise with the other ones, we're just copying this all the time. Copying that sign, it's going to be an equal to sign. Okay, so 8 is going to be a solid dot, but we can't have 5 being equal to, so that has to be an open dot for sure. Okay, you can do the test intervals. Left side here is going to be 0, 6, 10. Okay, if I put in 0, 0 plus 8, 8 divided by negative 5, that's going to be a negative number, and that is less than or equal to 0, so that's true. If I put in 6, we'll get negative 6 plus 8, that's 2, over 6 minus 5 is 1. 2 over 1 is 2. That is not less than 0. No, this one's also going to be a true. Okay, so we want outsides. We want x's that are less than 5 or x's that are greater than or equal to 8. The 6, the example problem for 6 for the story problem, guys, it's a good problem. It's just the numbers are so big for like our calculators that it's really not worth me going through and doing it, because I'm going to have to zoom out so far and then keep readjusting the screen a bunch. Read through that one, give it a good shot in the homework, and we can talk about it in class. But just make sure you read through the book example with that one. 7, find the domain of a square root. Okay, underneath this needs to be greater than or equal to 0. Even though we just did a little bit of work with imaginaries. All right, find the domain. We want our square roots to be greater than or equal to 0. Okay, so we could start off by dividing everything by 6. That's not completely obvious, but we could do it. 0 divided by 6 is still 0. This is going to drop it down to 36 minus x squared. What we have now is a difference of squares, but it's in the other order than what we're used to. 6 minus x, 6 plus x. All right, so our answers here are 6 and negative 6. We'll start off with testing 0. Is that going to make it true? Yes, 0 does. 216 minus 0 is greater than or equal to 0. So that is yes. These other two are going to be no's on the outsides. And these are greater than or equal to, so these are both going to be solid. So we're between. All right, folks, there you go. Again, it's not a terrible problem. It's just that the numbers are just so terrible. You're not going to be able to see it very well on my graphing calculator. So you're going to want to look through the book for that one. Otherwise, these shouldn't be too bad. All right, thanks for watching. Let me know if you have any questions. We'll see you in class.